Logarithmic differentiation. How do we go about differentiating a function y equals a to the power of b, where a and b are functions of x and a is greater than 0? Well, the first thing we would do is take logs of both sides. So if we use the natural logarithm, have ln of y is equal to the ln of a to the b. Note we don't need to have the modulus of a to the power of b because a is greater than 0, so it's always going to be positive. Now, using logarithmic rules, we can take the power of b outside of the logarithm to give b lots of log of a. From here, we can then differentiate. So the derivative of the log of y is equal to the derivative of b log a. And we will show how you do this in an example. Okay, so our example is y equals x to the power of x. So the first thing we're going to do, as before, is to take log of both sides and then take out that power. So we've got ln y, that should have been a log, natural logarithm, is equal to x natural log of x. And now we can differentiate. So the derivative of natural logarithm of y, and notice we're differentiating with respect to x, so it's going to be implicit differentiation, is 1 over y dy by dx. If you're not sure about this step, have a look at my video on implicit differentiation. Now this is equal to the derivative of x natural logarithm of x. So we can then use the chain rule to differentiate x log x. So we're going to use the chain rule is the derivative of uv equal to u v prime plus vu prime, where uv prime is duv by dx, v prime is dv by dx, and u prime is du by dx. So we're going to have u is going to be x, u prime is equal to 1, v is ln x, don't know why I did that, and v prime is 1 over x. So the derivative of x ln x is equal to uv prime, so x 1 over x plus vu prime, which is ln x. Now this cancels down to 1 plus ln x. So going back over onto the left hand side here, 1 over y dy by dx is equal to 1 plus ln x. Now we can multiply both sides by y to make dy by dx as subject. And going back to the original question, up here we have that y is equal to x to the power of x. So we can substitute that in, so that we have dy by dx is equal to a function of x, which is x to the power of x plus x to the power of x ln x. So now we'll have a quick recap. To recap, first step is we take logs of both sides. Step 2, we take the power out of the logs. So we had x to the power of x, took the logarithm which was log of x to the x, then we took the power down and we had x log x. The third step is to differentiate. which we do implicitly. And then finally, we will sub in y using our original question so that we have it in the form dy by dx is equal to a function g of x. And that is logarithmic differentiation. Thank you for watching.